back today to talk a little bit about the derivative. Now, you were given the definition of a derivative in class as a limit. So if we start with y being a function of x, then we define the derivative of this function as being the limit as x changes and gets close to 0 of this f plus delta x minus f of x, all divided by this delta x, our small change in x. So let's suppose that we have 2 over x as our function. Then the way we're going to calculate this derivative is going to be by plugging x plus delta x into this function here. Subtracting out 2 over x, which is the function value, and then dividing the whole thing by delta x. Now this requires some algebra, and honestly, this is the point in the process where it is easy to make a mistake or to get lost. Since we have 2 fractions that are being subtracted, the way we do that is by finding a common denominator. The common denominator is x plus delta x times x. This fraction here, if we want to convert it to having the denominator x plus delta x, you'll notice this denominator is missing the x. So we're going to multiply the numerator and the denominator by the x. And then this denominator is missing the x plus delta x. So I'm going to multiply this negative 2 times the x plus delta x. I am also still dividing by this delta x. So now I'm going to start simplifying. 2x minus the 2x cancels out, or adds to 0. And at this point, I can divide numerator and denominator by delta x, because delta x isn't 0, it is getting close to 0. So it's now at this point where I can plug in a 0 for delta x, and I don't receive a problem, like 0 divided by 0. Remember, that's more work. So here, at any point in the process, if you try to plug in a 0 for your delta x, you're going to notice that you get 0 divided by 0, which just means more work. Here, if I plug in a 0 for delta x, though, I do not receive a 0 divided by 0. I actually get a negative 2 over x squared. And you'll notice that it's at this point where my limit sign is removed, because this is where I actually applied the limit operation. I let delta x approach 0. That's how you find a derivative using the definition or the limit definition of a derivative. Thank you very much for joining me, and remember, if you're not having fun, you're not doing it right.